is the quadratic formula. We've been doing this for a week now. But the one thing that I want to make sure that we know, last week all of the equations were pretty much set up for you, and I'm going to write this just so it's a little bit easier to read. All right, does that show up a lot better? All right, so with the quadratic formula, where do A, B, and C come from? Where does A come from in the equation? And what's beside? It's the coefficient for what term? Is it next to x or is it next to x squared? Yeah, A is always next to x squared. Now what's B always next to? Just an x. And then C is always the constant. Now everything last week, what were our equations equal to? They were equal to 0. So they do have to be equal to 0 before we can start. So today's equations aren't going to start out with equal 0. We're going to have to make them equal to 0 and then do the quadratic formula. So today we're going to see different things on this side. We're going to have to move some things around. And so we want to make sure that they go in order. So we always want ax squared first, bx, the x term goes in the middle, and then our constant equals 0. So for this first example, I want you to, we're going to go through this, and you guys all have your calculator, so we'll calculate it all together. All right, so we have 5x squared minus 135 equals negative 2x. Now, for this specific example, it's not equal to 0. So we always like this to be equal to 0. So how can I move a negative 2x over to the other side? Do I add it or subtract it? I'm going to say we add it. So we're going to add this 2x to this side. Now whatever we add to this side, we have to add it to the other side. Now the x term, don't we typically like that as the second term? We always like our x squared and then our x term. So I'm actually going to write this plus 2x here because we want it to go in between those. And so we will now have a 5x squared, and we added the 2x over, so it's plus 2x minus 135 equals 0. Once you have the equals 0, then you can do the quadratic formula. So the first thing we do is we make it equal to 0, and then we can do the quadratic formula. Now say that's not too bad, is it? So we just got to move something over today. So if we want to do the quadratic formula, all right, if A is 5, B is 2, and C is negative 135, what do we get for the opposite of B? Negative 2. What's B squared? 2 squared is 4. Now we got to take negative 4 times A, which is 5, times C, which is negative 135. And I'll say, I'll double check that. Negative 4 times 5 times negative 135. Positive 2700. Do you guys all agree with that? And then 2 times A. What is 2 times 5? Guys, what's 2 times 5? 10. All right, so once we have that all set up, we are good to plug what we know into the quadratic formula. So we've got our negative 2 plus or minus. Inside the root, we got 4 plus 2700 divided by 10. Now, we have to take the square root of 2,704. Because if we add those two together, for those of you that actually have a square root button on your calculator, is this a perfect square or do we get a decimal? I'm going to say, I think it's a perfect square. Now, if you don't have a calculator, you can still simplify this. What is he? All right, so if you want to simplify this, if you don't have a calculator with a square root button, if I divide this by 2, I get 1352. Can I still divide that by 2? Divide that by 2, I get 676. That's still even. I'm going to just keep dividing by 2 until I get an odd number. All right, what's a number I can divide 169 by? It's a perfect square. Guys, what can I divide 169 by? 13. Okay, so this one is a perfect square, but I want to show you guys, if you do the cake method on this, you have all pairs. What is 13 times 2 times 2? That's 52. So on this one, do we have any leftovers? No, so it's just -2 plus or minus 52 over 10. So if it's a perfect square, you have all pairs, so it's just a whole number, 52. Now, if it is a perfect square, we have to add and subtract still to get our 2 answers. So if I add those, what is -2 plus 52? All right, 50 over 10 gives me 5. And if I subtract those, I get -54 over 10, which I can reduce that to what? If I reduce it by 2. I agree with the fifth. What did you say for the top? What's half of 54? 27. All right, so just like last week, sometimes you are going to have perfect squares, sometimes you won't, and so your answers will have square roots in them. But the first thing I want to make sure today is we set them equal to 0 and then do the quadratic formula. What do you guys think? Are you guys awake?
No.
Why not?
I don't know why, but I'm super tired.
I'm gonna say the game was over it. The game was over at 10. I mean, if you watch the trophy and stuff, like. All right, are we ready to try another one like this? Okay. Let me switch out. Let's go. All right, I want to make sure it works out to something different. Okay, you guys can see that, right? P squared plus 7p equals 13. Okay, do we like equations to be equal to 13?
I thought it was 0.
Okay, we want it to be 0. So, Landon, that's good. You definitely want it to be equal to 0. So, if I want this to be equal to 0, how do I get rid of this 13? Do I add it or subtract it? Yep, we're going to subtract the 13 here, and we also have to subtract it over here. So this equation, we always want our p squared first, and then our 7p, and then afterwards we'll write minus 13 equals 0. Then we can do our quadratic formula. All right, are we ready to do this one together? All right, what's the opposite of b? -7. What's b squared? 49. -4 times 1 times -13. positive 52. And 2 times A, 2 times 1?
2.
2. Alright, so we've got 49 plus 52 in our square root. What happens when I add those? What do I get? 101. Now, I want you guys to take a look at 101. If I wanted to simplify this, can I divide it by 3? You guys have your calculators. Is it divisible by 3?
No.
Alright, is it divisible by 5?
No.
No. Is it divisible by 7?
No.
You do know I'm just going through the prime numbers, right? And I skipped 2 because it was odd.
Yeah.
Alright, so then the next prime number is 11. Does it divide by 11? Does it divide by 13? Alright, 15's not prime. What about 17? What about 19? Alright, 21's not prime. But what about 23? Hey guys, what do you think about 101? Yeah, it's prime, so we can't simplify this one. So we just leave it as our regular square root. This one is prime, so it doesn't simplify. So we just leave it as it is.
So if we just have all prime numbers?
Huh?
We should just have all prime numbers.
No, we can't have all prime numbers.
Why? It seems like a way easier process.
Well, sometimes it is easier. Alright, you guys gotta tell me what you're thinking. Do you have any questions on 1 or 2? Alright, I've got 2 more. I'm going to say we're doing notes today, we're practicing tomorrow, there's no assignment tonight. But let's take a look at another one. Now, 3 and 4, these next 2 examples do look different than the beginning ones. 3x squared minus 6x minus 7 equals 4. Alright, what do I not like about this?
It's not 0 at the end.
Okay, we want it to be equal to 0, so how do I get rid of this 4? Alright, I'm going to subtract it. Now, on this one, where else can I subtract the 4 from? The 7. Because on those last 2 examples, there was no like terms to combine it with. You just moved it over. But since there are more constants, that means a number without a variable. So this number doesn't have a variable, so we're going to subtract the 4 from the negative 7. So this becomes 3x squared minus 6x. Now what is negative 7 and a negative 4 make? Minus 11 equals 0. Then we do the quadratic formula. Alright, so what's the opposite of b? Positive 6. What's b squared? 36. Negative 4 times 3 times negative 11. 132, and that's a positive. And then 2 times a? Hey, you guys are a lot more alert. Did it just take you a second to get back into the hang of it? Alright, so we can plug this in. Alright, 36 plus 132. You're going to say, what am I going to take the square root of? 168. Now, this is definitely not a perfect square, so we are going to have to simplify it. So, if I take 168, can I divide that by 2? What do I get? 84. I can divide that by 2 again. Yep, and divide that by 2 again. And then I divide that by 3 and I get 7. So we have some pairs, right? Alright, we have a pair of 2s. Hang on just a second. Hello. We're in the middle. I have one more example. Then can I send him over? Okay. Alright. Bye. Alright. So how do I rewrite this? So I have a pair of 2s. That goes on the outside, right? What's left for the inside? A 2, a 3, and a 7. So that would end up being, yep, 2 square root of 42. So we are going to rewrite this as 6 plus or minus 2 root 42 over 6. Are we done? All right, we've already simplified the radical, but look at the coefficients. We can divide 6, 2, and 6. We're going to divide those all by 2. So what will that become? Yeah, you don't have to write that 1 in front. You can write it if you'd like to, but it's not necessary to write the 1 with the root. So we have 3 plus or minus the square root of 42 over 3. Alright, do you guys think you could try one like this on your own? And if I remember right, this one's going to be a perfect square. There we go. Everybody to freeze for just a second. Do you guys agree with that?
Oh, yeah.
Subtract 10, negative 80, and a negative 10 make negative 90. Alright, so those are your A, B, and C values you should be using for the quadratic formula. If you don't have those, make those changes. So I'll show you guys the next part of what I have. I have this. Okay. What do you guys think about the negative b and the b squared? Are we okay with those two numbers? What about the negative 4ac? 2a is 12. So whenever I plug those in, I add those because those are both positive. Now, 2,304 is a perfect square. What's the square root of that? 48. So this one we do have to add and subtract. So I do want to show you guys, if you don't have a calculator, if you wanted to simplify this, you're going to have all pairs. So 2,304 divided by 2 is 1152. Divide that by 2, and I get 576. Keep dividing by 2. And I get 288, divide by 2 again. And I get 144, divide that by 2. 72 divided by 2. And I get 36, divide by 2 is 18, divide by 2 is 9. Alright, so I kind of sped that up. Yes, Ben?
Why would we divide by 12, like negative 12 plus minus 48? Why could we simplify it to negative 1 plus minus 4 over?
I'm not there yet. Okay, I'm not there yet. But that's a good question.
Okay.
So I just wanted to see, because you have a square root button on your calculator. Not everybody does. So if you have to simplify 2,304 on your own, I want to show everybody on this one, we have a pair of 3s and then a 2, a 2, a 2, and a 2. So we're taking 3 and then 2, 2, 2, 1, 2, 3, 4 2s. And so this ends up being 48 with no leftovers. So I do want to show you guys something. Ben actually just made a really good point. Do you guys notice that you could reduce this already? So if you reduce this, you can reduce first, or you could just add and subtract here and reduce each answer. So some of you maybe do this. Some of you maybe are going to take negative 12 plus 48 and divide it by 2. So then you would get 36 over 2, which is 18. That's one answer. 12. Sorry, never mind. 3. You guys like that answer better?
Yeah.
All right, sorry. See how easy that is to just make a mistake on your denominator? All right, then the second answer, you would take negative 12 minus 48 divided by 12, which is negative 60 divided by 12, which is negative 5. Now, this is whenever you add and then reduce at the end. Some of you might have realized you could divide that by 12 and just become negative 1 plus or minus 4. What's negative 1 plus 4? That's 3. Negative 1 minus 4 is negative 5. So you can reduce first and then do the adding and subtracting, or you can wait and reduce it at the end on each one. That's totally up to you. So on this one, we are looking for 3 and 5. Now tomorrow we're going to do a mixed review with some things that are equal to 0 and some that aren't. Tomorrow's just practice. We're going to get the whiteboards out. And then on Thursday, you guys will have an in-class worksheet over this stuff.